This tutorial will review cutting a groove on the OD of a part on a Mazatrol lathe. I'll be adding this cut to an existing program, open for editing. This drawing shows the part to be processed. In this process, I'll cut this groove thread relief on the OD. Begin by selecting turning. Next, select T-groove. We are making an OD groove, so select out as the machining part. There are 6 different patterns we can use to define the groove. On some controls, selecting the question mark at the top of the screen brings up a help screen. This help screen gives us all the basic information needed to create the groove. There is the simple square groove and multiple types of tapered side grooves. There are also 2 different types of chamfering cutoff grooves. These allow for chamfering either the remainder left in the chuck or the part to be cut off. The drawing shows a simple square groove, but I'll use a number 2. This gives me a bit of taper into the threads I'll cut later on the 4-inch OD. Number of grooves is for making multiple identical grooves. I'm just doing one. Pitch is only used for multiple grooves. It's worth noting here that the pitch is measured differently on different types of grooves. The pitch is measured based on the groove definition start point, which is shown as a hollow circle in this graphic. As you can see, on some grooves it's the front of the groove, while on others it's the back of the groove. In any case, we have a 0 pitch with only one groove. In a number 2 groove, the width is measured at the top of the groove as shown here. For my 0.25 groove, I'll make it 0.3 inches for a 50 thousandths wide taper. Finish allowance is how much stock to leave after the rough cuts for a finish pass. To get a nice clean groove, I'll save 10 thousandths for a finish pass. The control has given me the same groove tool for both rough and finish. Going to the tool data window, I can see this is a 0.12 wide groove tool. This will fit my groove fine. I'll skip priorities for now, and move to cutting pattern. The 3 available cutting patterns are simple plunge, bidirectional, and unidirectional. These patterns are described in this excerpt from the programming manual. It should be noted, the finish pass is a contouring pass, and the same on all 3 pattern types. I'll use a type 0 pattern. Max depth of cut sets the pecking depth of the groove tool. Using the Coding L Auto Set button has given me a depth of 78 thousandths. This means the groove tool will plunge into the cut 78 thousandths. Then back off the amount given in parameter TC74. Then plunge another 78 thousandths and repeat to the bottom of the groove. Note, TC74 is available as a TPC setting, so you can alter it for just this process, without changing the original parameter. I'm fine with the surface speed, and I'll set the feed rate to 5 thousandths per revolution. I'll turn on coolant for this tool, with an M8. For the finish tool, I'll use the Coding L Auto Set. This looks fine, and again I'll turn on coolant. It takes only one line to define the groove shape. I don't need a corner radius or chamfer, so I'll go right to the start point. As shown on the help screen, the starting corner is at the front of the taper. The final corner is represented by this solid dot at the bottom of the taper. Looking at my drawing, the starting corner X would be 4 inches. The starting point Z would be 2.5 inches, minus my extra 50 thousandths, leaving 2.45 inches. Final point X is the bottom of the groove given as a diameter, at 3.7 inches. Final point Z is given on the drawing as 2.5 inches. Final corner gives the opportunity to define a chamfer or a radius at the bottom of the groove. We don't need that here. Taper angle is not necessary since we have fully defined the taper with a start and end point. Surface finish feed rate is an opportunity to adjust the finish feed rate of individual lines in the definition of a part shape. A new feed rate can be entered directly in inches per revolution. Or, the control will calculate one for you by using one of the available roughness codes shown. These presets are shown in this manual excerpt, as 1 being rough and 9 being very fine. When left blank, the feed rate from the Define Finish tool will be used. This completes the definition of the groove. Selecting the top line in the T-groove out unit highlights the groove I've just defined in the graphics window, where I can zoom and rotate, inspecting my work. If desired, the only change I might make in TPC is to alter the back off for pecking in TC74. I'm happy with the default, so I'll leave it alone. To see the details of my toolpath, I'll add an end unit, select Program Complete, and select Toolpath, to view the toolpath of my cut. For a clear view of the toolpath, click on the right side of the window, select Section, and select the ZX plane. To view only the groove cut, I'll use Path Restart. Select Path Restart. Select the first process in unit number 6, and click OK. Using Path Step, I can clearly analyze the toolpath, including the pecking action and the final finish pass movement. Returning to the program page, delete the end unit. And we're ready to continue programming the part.